Hello, everybody. Welcome to joint webinar with Genano and Cleamix. My name is Panu Vilska. I'm CEO of Cleamix, and here with me in the studio is Mr. Niklas Skogster, CEO of Genano. Welcome.
Thank you, Panu, and hello to everybody.
And on the line, we have experts from National Research Center. Dr. Satu Salo, welcome.
Thank you.
And we
And
have,
hello.
Thank you, Satu. And we have Dr. Ilpo Kulmala, senior scientist from Technical Research Center of Finland. I'm not sure if he is yet on the line. We also have the technology director from Genano, Mr. Juhani Tulkki. Welcome.
Thank you.
And we also have Dr. Janne Kuusela from Mikkeli Central Hospital, but unfortunately he got an emergency call, so he had to go for duty right now. So he will join us later as the situation develops. Hopefully he will be back with us. And welcome everybody once more. And today's topic is COVID-proof interior air quality. So we are discussing today about various methods and technologies, how you can create and refine your corporate clean air strategy. Both myself and Mr. Skogster, we have been frequently asked about how do we do safe interior air in all aspects. And we have both come to the conclusion that there is no single simple method. If you want to get clean air, healthy air, and protect your company and your employees and your families against the pandemic risk, you have to apply a multitude of methods, a combination of different approaches. And therefore, we decided to arrange this joint webinar so that we can discuss this topic in more detail and explain about the strategy and also the different elements that make your corporate clean air strategy. So, Mr. Skogster, can you please tell briefly about Genano?
Yes, I'm very happy to be part of this webinar here, and thank you, Panu, for the great introduction. Genano is a technology company, 20 years old, developing air purification and air decontamination technologies. We've been around in the healthcare industry for 20 years and also developed solutions then for how to clean and monitor and improve indoor air quality, mostly related to sick building syndromes. We have also solutions and projects ongoing in industrial applications where we mostly clean industrial processes and make the process environments clean. Now suddenly, during this very interesting year 2020 with the global pandemic on, our business has changed so that the indoor air quality business is more of preventing people from other people and preventing us from viruses in the air rather than preventing us from bad indoor air quality related to the sick building. So we are afraid of each other, and we are afraid of sick people around, and we are afraid of all the viruses which are airborne and traveling around in public spaces, maybe in offices, in sports facilities, in healthcare facilities. And this is a new area where we can help. We are sitting here together with Panu today next to a Genano air purifier, and we don't need to be afraid when we have this friend here next to us cleaning up the air, and this air purifier eliminates the living material and the living viruses from this room and this space where we are today. So at least I feel safe for the moment.
Thank you, Niklas. Actually, we were wearing masks when we came in here, but we decided to bring one of their devices, and that gives us sufficient confidence level that keeping a little bit distance, we can safely have the interaction here and this webinar without wearing a mask. And I guess it's also more convenient understanding what we say. All right. So Cleamix, we are a company in decontamination business. So we have a new, very compact and very effective method for generating hydrogen peroxide vapor. And hydrogen peroxide vapor is used for deep decontamination of hospitals, medical facilities in general. But now that there is a very compact and high output technology available, it can be a mobile system that can be used in ambulances, in general logistics, and multitude of different industrial applications as well. Those who have participated in our webinars before, they have seen this device here. And just to give some comparison, this 9.5 kilo device is delivering 4 to 7 times more hydrogen peroxide vapor than earlier generation systems weighing 100 to 200 kilograms. All right,
So Panu, we can say that we are pretty safe now because we cleaned our hands, we had the mask on, which is the basic cleaning principles. We have an air purifier, which is cleaning continuously. And then we have made a scheduled cleaning with the hydrogen peroxide here in this area. So this should be now super proof.
Well, as proof as, or as safe as is reasonably achievable. Let's put it this way. So let's go to the main topic. So there are 3 elements of clean air and clean surfaces. And in reality, clean surfaces also contribute to clean air. Because if you have for example, a mold-infested building, it means that you have a lot of mold spores in the air, which means that your air is not clean. So those 2 things go hand in hand. So we decided to illustrate this approach as a triangle. One side of the triangle is a general hygiene and cleaning procedures. This is what includes washing your hands, wearing a mask, making sure that you don't have any unnecessary rubbish, and general cleanliness.
Regular cleaning.
Yes, it means
premises.
physical cleaning of the premises, wiping everything. Now, the second important element is the effective air filtering and decontamination. So this is really what the Genano is about. I think, correct if I'm wrong, Niklas, but this device, from this volume, it filters and decontaminates the air approximately 4 times per hour, or?
Yes, of course, it's all dependent on the size of the premises where you are, the air volume, but right here, yeah, I think it's actually cleaning it more than 4 times an hour for the moment. There are different recommendations out there in the public. Somebody say that ventilation and air decontamination 3 times is enough, but we have here the Institute of Health in Finland recommends that every 15 minutes you should change the air, and that is based for the COVID time to infection to spread 15 times, so around 4 times in an hour, and we're running it now on a little bit more than 4 times an hour in this room where we are now.
And then the third side of the triangle is the what we call deep decontamination, and that's what for example hydrogen peroxide vapor is about. So when you use a gas phase substance, it means that it really goes everywhere. For example, if this table gets wiped, not every time we remember to clean every cable or underside of the table or the fabric of the chairs. So the periodical deep decontamination is a process where we make sure that we have a 6-log result on reduction of microbes, and this is typically the hospital standard. Now, of course, if we are in an office environment or public transportation unit or similar, we don't need to go to 6 logarithmic reduction. but it's enough that we kill what is the pandemic threat and the most common threats in such environments. Satu, for the benefit of the audience, can you give us a practical example of what's the difference between 4-log and 6-log decontamination and what it means in reality?
Yeah, in reality, these 6 logs colony forming units per square centimeter or liter of air are very rare. So it's extremely big amount of microbes. So about 6 logs is 1 million microbes. So in practice, these amounts are way smaller, and if you prefer percentages, 1 log unit is 90% reduction, 2 log units reduction is 99% reduction, and so on. So if that makes easier to figure out the log numbers.
We've seen in the news and other public communication, some experts have been commenting that if there is 99.9 reduction of microbes in the air, that is substantial reduction regarding the coronavirus risk. Is that true?
Well, always there is risks, and zero risk does not exist. But of course, this is quite big reduction already. This 3 log reduction. Yep.
Yeah, thank you. So there are many different approaches to air filtering, purification, and decontamination. And of course, not everything can be called decontamination. So decontamination really means 6-log approach. However, as we know, there are multiple different methods. So let's, for a moment, discuss about the methods and what are the elements of high quality or indoor air quality aspects. So first of all, I think dust and particles, that's one of the most easy to understand.
Yeah.
And that
Exactly.
is something that we can...
Substance flying around in the air.
Substance flying around in the air, and that's something that a simple filter can remove.
That can also be fibers that might come from isolation materials or from some kind of seals in the HVAC system. So fibers should also be included in this fixed particles and fixed substances which we have around in the air. There are smaller of them, there are fine dust, and there are ultrafine dust. And let's say so that the ultrafine particles, the most smallest, they are so small that they are flying around in the air all the time. They are not lying down on any surface because there's turbulence and air movement all the time that makes them and keeps them flying around. When they are flying around, they are also very dangerous because they can enter the human body through the skin and go directly to the bloodstream through the skin. They are so small.
You mean the fiber?
The ultrafine particles,
right.
And that makes them then to be dangerous to human. There's a lot of investigation and research ongoing on the effect of ultrafine particles for the human body. There are certain tracks and traces that say that when they gather up in organs, we will have physical problems, and there's even somebody researching for the moment that could Alzheimer's disease have something to do with the ultrafine particles gathering up in the body.
But now with the dust, we have the next level. We have microbes in the air, and when you have dust, you have a carrier mechanism for viruses.
Exactly.
So that's why I think, Satu, do you agree that when we reduce amount of dust and particles, we also reduce the carrier mechanism for viruses?
I agree. Yes, it's easier for microbes to survive if they are attached to something than just flying naked on the air by themselves.
Right. And then, of course, the VOCs, volatile organic compounds,
gaseous
compounds, especially in urban environment and industrial environment. That's one thing which affects the indoor air quality. And chemical emissions, odor, smell, humidity is one factor. Too high humidity is not healthy, and very dry air might not be healthy. That's one factor on the indoor air quality. And then some people have mentioned also, we took it here on the slides, that the air pressure differences.
Exactly. Yeah, that's very important also to mention the air pressure, that especially in sick buildings and buildings with problems in the constructions, there might be microbes in the ceilings or in the walls, or maybe in the floor somewhere inside the construction. Then let's say easy way to help it out is to overpressurize that building, and that's why you try to avoid those microbes and gaseous compounds to enter into the indoor air. But there are studies also showing that already a 20 Pascal overpressure affects the human body, and we've seen cases where 20 Pascal overpressure, which is actually very small overpressure, makes people faint in schools and in public areas. So the overpressure is an important factor here.
Okay, so then we have various purification methods. So let's have a look at those. One of the very commonly mentioned is ultraviolet light, and people have seen UV light systems in grocery stores near the fresh food counters. It's been used inside, for example, the heat exchangers, heat pumps, and there have been many claims that, for example, pandemic situation justifies using UV light in public areas. What do you say about this usability of UV in this? What do you see benefits and challenges?
Well, okay, it's shown that UV works, but you have always to remember that UV also includes a time axis, because UV light affects the RNA of the viruses and destroys that one, but it needs some time. The other aspect with the UV light is that there are shadows around, and for example, UV light applied here in this room from the ceiling would not clean anything under the table here, for example, or behind any shadowing object. I've even heard that somebody say that particles flying around which are bigger than the viruses or the microbes might create the shadow, so the particle could protect the virus in the UV light.
So in general, I think one of the challenges with UV is the exposure time.
Yeah, time axis and the shadow.
Yeah, and the shadows. So can we say any specific use case where UV light is justified?
Closed environments, for example, cleaning handrails in an escalator in a shopping mall, that could be a pretty good thing. Or cleaning some kind of devices in a hospital where you put them in a closed counter or in a closed cabinet. That could be good cases for UV light.
But maybe not necessarily office environment or home.
No, I would not apply it.
So then one of the most common acronym we see is HEPA filter. And HEPA filters are, as we know, very effective in capturing all sorts of dust. And one of the good benefit about HEPA filter, for example, is that when talking about our technology, hydrogen peroxide decontamination, HEPA filter has no effect to it. So the air circulation system can apply HEPA filters. Now, the HEPA, looking at the HEPA filter as a filtering method indoors, how effective you see it?
Well, HEPA filter is an old invention. I think it was somewhere 1950s when it was invented, and there's a massive industry behind HEPA filters and lobbying for its usage and its effectiveness. In basic, HEPA filter is a mechanical mesh, and HEPA filter catches even small particles, even ultrafine particles, the best HEPA filters. But the downside with the HEPA filter is that the cleaning efficiency is not constant. That when the mesh starts to be saturated, more and more particles are attached to it, the HEPA filter's cleaning efficiency goes down as a function of time. The other problem is that when the filter is saturated, you still press air towards the filter itself starts to be a particle source from the air pressure pushing through the smallest particles. So at the high saturation point, the filter itself becomes a particle source. There is also one aspect with the HEPA filter. Yes, it catches viruses, microbes, it catches the particles which are the virus carriers, but it doesn't kill them. It doesn't eliminate them. It just catches them. And the particles stay alive in the filter unless you do something to it.
But for example, in heat pump heat exchangers, when there is UV light directly to the HEPA filter, it increases the efficiency.
It increases the efficiency, but once again we have to remember the shadow problem.
Yes, exactly.
And the shadow behind the other already gathered particles in the HEPA filter, and then the exposure time.
Now, usual combination is HEPA filter with active carbon. And I think active carbons, one of the big benefits is that it catches organic compounds very efficiently and reduces odors from the air.
Yeah, it's mostly used for gaseous compounds filtration, and that's where it's very effective. There are different kind of combination of active carbon that you can use for specific uses. If you have some specific gas that you want to filter out, you can combine specific active carbon substances then when you can affect those.
But the full mask used by, for example, biohazard teams, it's technically a carbon filter combined with a HEPA filter.
Exactly.
So it catches viruses, but it's having it.
But it doesn't kill them.
Yeah, it doesn't kill them, and having 6 log efficiency, you run out of the carbon's capacity quite quickly. So then one of the listed methods is non-thermal plasma, and that is actually what Genano is doing. So on the next slide we are going into more detail on what NTP, what non-thermal plasma is actually about.
And then you had the electrostatic filter.
Yeah, electrostatic filter is another one, and electrostatic filter is basically based on charging particles as they go through the filter, and then you have the opposite charged plates or other elements which capture the particles. Now then we have a full site decontamination, and now as we mentioned, hydrogen peroxide vapor is one method, and then there are some let's say other approaches like using formaldehyde, using chlorine or ethylene gas, and formaldehyde has been somewhat popular, especially in healthcare, but Satu, what do you think if you compare like use of hydrogen peroxide and formaldehyde when treating medical facilities?
First of all, this hydrogen peroxide does not leave any chemical residues because it's going to be water and oxygen at some point. So that is already one benefit in this comparison. Both are harmful for people when people are in the same place when this gas is in air, and but both of them are also efficient. So in that way, maybe it's not that big differences.
Yes, and also chlorine gas has been used, but I think there's a corrosion problem with electronics if chlorine gas is used for this purpose.
Yeah, and again, it's chemical residues, and chlorine is much more well, hydrogen peroxide is more environmental friendly than chlorines.
Yeah. And then of course we have combination devices, combination solutions. As we mentioned, there are filtering technologies that combine multiple methods in parallel. So let's. The one thing we didn't mention, ozone, and I think ozone has been mostly popular for especially removing odor.
Yep, ozone works for removing odors. For example, a used car which has a bad smell and somebody has been smoking in that car, it can be used once or twice in that car. Ozone is harmful for the human body, and there are certain restrictions on how many ppbs we should be exposed to. Ozone has also negative effects on plastics, for example, and surface materials. It breaks down the construction of the plastics. That's why it's recommended that don't use it more than twice in a car, for example. Also,
wow, that's a problem indeed. So now next, can you, Niklas, just in a compressed manner explain the Genano principle? How do you do this non-thermal plasma?
Yeah, Genano technology is based on a non-thermal plasma phenomenon, a little bit like the electrical filtration. But in the Genano technology, the filtering unit is a tube formed shape around 70 centimeters long and 30 centimeters in diameter. In the middle, there is a so-called needle pipe to which is attached then strings which are charged by high power, and they are like glowing because of the electricity in those needles, and there's a cold plasma phenomenon created inside that collector tube. Then you lead in contaminated or dirty air from the bottom of the tube. There's a fan on top which is driving the air or moving it. You lead the air through the plasma field, and the particles and the substances in the air will be negatively charged during the travel inside the tube, and they will be attached to the oppositely charged inner wall of the cleaning tube. During that filtration, living materia, bacteria, viruses, mold spores, they will have a pretty high electrical shock also, and the recent research results say that all the living materia is killed and eliminated during this filtering process. We've come down to a filtering efficiency of going down to 3 nanometer sized particles. We have been able to filter with this method. Most likely the filtering can catch even smaller particles, but the measuring devices used go only down to 3 nanometers. So 3 nanometers is what we claim that we can catch.
I need to make a question to Satu now. 3 nanometers, is that high or small figure when we discuss about filtering technology?
Well, if you think about microbes, it's very small unit, this 1 nanometer. The viruses are close to that, but way bigger than 1 nanometer, and the other microbes, they are close to 1 micron So even bigger
So,
in that way.
so you have a justified claim to say that it really removes viruses.
Yes, yes, that's how we say. There, it's commonly known that the COVID virus is something between 60 and 120 nanometers for the moment.
So way bigger
Yeah,
than
yeah.
your capacity. Okay, so then let's then have a look at what we are doing. So as said, Cleamix has a new methodology, new patented technology for creating large quantities of hydrogen peroxide gas. It's also a Finnish company. We've been around for almost 5 years now, and this innovation originated from Finnish military requirement for having a portable field portable decontamination devices against biological and chemical threats. And the result of this work was first of all founding of Cleamix, and then refining the innovation. And as said, this is wholly domestic product, and right now we are shipping to 15 countries, and we are certified supplier for NATO, and we do very close and very mutually beneficial cooperation with our government. Let's call them government organizations. And now with the COVID outbreak, the demand for decontaminating all sort of facilities have become of a very high focus. And of course, our technology, which is originally a decontamination technology, 6-log reduction, that was what we benchmarked. But now very recent research results, which we will touch a little bit later on, they show that coronaviruses and other envelope viruses, they are very easily killed with hydrogen peroxide vapor. So we don't have to go 6-log for the pandemic protection, and we can actually deal with less. And also it means that larger spaces can be treated. And so some of the benefits, of course, as Satu mentioned, this is very environmentally friendly because hydrogen peroxide dissolves into water and oxygen, so it leaves no residues, and it doesn't harm any of the electronics or sensitive materials. This chart is just showing the different microbes in order of their vulnerability to hydrogen peroxide. So the easiest to kill are the envelope viruses. So that means, for example, the current pandemic, the coronaviruses. And the hardest to kill are bacterial spores, like anthrax, for example. And this system was designed to kill anthrax. So, well, the common question is, does it work on COVID or coronaviruses? Yes, it definitely does. And it's way easier than dealing with real chemical or biological warfare agents.
So actually, we have a pretty good combination here against COVID.
Exactly.
That Genano can filter and eliminate much smaller bacteria and viruses than the COVID is, and Cleamix can kill much harder and difficult bacteria and viruses than COVID. So,
yeah, we can call it a solution.
Yeah.
Okay, so let's go to the use cases. So this was actually what many of the audience have been indicating that they want to hear about this, not just theory, but let's go to real life. And if we have a most common use case, office. Today, people work remotely, they video conference, but at least I do claim that business suffers in many ways. You can't do everything remotely, and meetings may not be equally effective when people can't have interaction. So now the fact is that SARS COVID-19 is airborne. I guess there is no doubt about it. Satu, I don't think anybody anymore tries to deny that that COVID virus, SARS COVID-19 is airborne. I mean, nobody denies that anymore.
Yeah, according to several studies, it can move from place to place via air. Yep.
And also, what's been let's take it just as a proven fact that this virus survives on surfaces, and it can survive for a very long time. The estimates are from 72 hours to even 2 weeks. So I think it's still safe to say that it can survive more than overnight in order to
That's
avoid
true.
any debate on that. So then, what can be done in the office space? So I think we both agree that it's very essential to reduce the amount of viruses from the air. And now we come to this second side of the triangle. We presume that the office is being kept clean. People follow hygiene, they wash their hands, and they wear masks and so forth. But then what can be done is the most effective achievable reduction of viruses in the air, and that's what this real-time air filtering and decontamination is about. Because the less you have viruses in the air or microbes in the air, the less they touch on surfaces.
Exactly.
And it also means that when you do periodical deep decontamination, you have less biological load that you have to deal with.
That's true. By the deep decontamination, you take down the level significantly from where you start the continuous cleaning. I will come back, Panu, to what you mentioned about the office and what's happening in the corporate world and in the companies today. The way how we work is definitely going to change, and it's changing already. We see that people are staying at home, and we are having our teams globally around the globe. We see it in the morning traffic. There's less rush and traffic in the morning and in the afternoon. We see that public transport has less passengers and so on. Definitely something is changing. But how long can we continue with this? People want to meet each other, and people want to interact with each other over physically also, and not only over Teams. They want to meet in the cafeteria. They want to meet in the lunch restaurant, at the coffee counter. They want to interact and test their ideas. And I've said that once the best inventions and innovation happens when people interact suddenly and not planned. So what will happen to innovation due to the fact that we are all sitting behind our screens and communicating our teams? Management and leadership is suffering. I feel it's much difficult to lead people and create feeling and spirit over a screen than doing it on site in an office where I have the people around. A lot of small communication, also walking through a desk and saying, hey, did you see that, and did you react to that, and hey, good job. These kind of things are left out in the distance working. We also see that people start to have psychological problems and mental problems sitting at home in apartments, maybe at the kitchen table or at the sofa in the living room. The walls are falling over them. They need to go out, and they want to go out. They want to meet other people. So these are new challenges we have in the working life and in the community and society now. And if we can do so that we can clean the offices and make it safe to be in the office by reducing the risk of airborne viruses or bacteria to spread, then we can most likely affect quite a lot of the society also.
Mm-hmm. So when we talk about this process, I actually have I thought about what is a good real life comparison. If you have a garden, you have also a problem with weeds. You have to take off the weeds.
Mm-hmm.
And the more often you do it, the less weeds you will have over the time. It means that it may be a difficult start, but when it becomes a routine, you finally have a garden with hardly any weeds.
Yeah, no, exactly. The analogy follows.
Yeah,
Oh.
but then we have also the challenge on how to get safely to the workplace. But let's have a look at the next slide, which is positioning of air purification units.
Yeah.
And
That's typical cases of how they can look in offices. That's from a few different offices. Taken pictures with different kind of Genano devices also. So, okay, they take a little bit of floor space, but they are pretty easy to install and place in the offices. They are all movable and they are all on wheels and they are all only needing an electrical normal plug socket, so you don't need to have any special installation arrangements or so. Just roll in, plug in, power on, and start to decontaminate.
so you simply do the dimensioning on what is the amount of air and how many people interact, and then you have some sort of formula on how many devices you need.
Yeah, you need to look at the premises so that you know that is there any obstacles that can hinder the air to move or any walls. There was in the picture also a sketch of one office which was consisted of smaller and bigger rooms, and then based on that floor plan we can quite easy make a first suggestion how many decontamination units are needed and how to place them and how to reach an efficiency that we then have more than 4 circulations or air changes per hour.
So let's go then to public transport and how this triangle of methods apply. And you will see a couple of coming slides where we repeat ourselves a little because the cleaning and hygiene, it applies everywhere. And what we mean with that again is that the mask protects you and it protects the other people. For example, in a commuter rail car or bus, you have people in very close proximity to each other. And in Asia, we have seen people using masks for years. And it's not really for their own safety, it's for the safety of others. So when you breathe out, the mask is also capturing the quite great deal of the microbes. So you don't have the you don't spread the infection if you are sick yourselves. But then, of course, there are some other common rules. The workplace is changing, but also companies can be more flexible. Not everybody has to be there 9 o'clock a.m. or 8 o'clock. People can adjust there when.
That's true. Yeah.
Not everybody
That's
can.
good,
You may have
good
children
idea.
you have to take to daycare or something like that. But if you can avoid rush hours, or you can at least try to avoid rush hours. And also, when you go into bus or train, it's very depressing sometimes to see that everything is full of trash or dirty. So those operators should really put more focus on keeping them clean.
Yeah.
Because that's more like that would be like a polite invitation that we care about you, right?
Yeah, but that's once again the basic side of the triangle, that the basic cleanliness and the basic tidiness, how to keep that in order. How often you clean the tube carriages or the buses or so on. How do you do the surface cleaning there and how you clean the seats and
Exactly.
so on. That's the basic.
And then just like in the office comes the air decontamination. So when it's a time of pandemic, of course there's a threat of urban pollution coming from outside, but when it's about microbes, I think there is less of that coming from outside. The microbial risk is already inside. So in addition to the basic cleaning and hygiene, then there might be methods of reduction of microbes from the air inside, for example, a bus, inside a train car, inside an airplane. Now, how do you think your technology applies to this use case? So, for example, a bus or train for a continuous filtering. Does it make sense?
Yep, it makes sense. And once again, we are talking about that we are the risk to each other. It's not the dirty air, polluted air in Delhi or in Beijing or in some other city, which is the highest risk. But it's the risk inside the vehicle itself, or the train or the carriage, and we create the risk inside there. There are methods where you can apply electrical filtration systems, for example, in the roof of that vehicle, and you can circulate the air inside and make it clean, same way like you do it in a hospital or in a laboratory or in an office. The same thing works in also in public transport.
And also when it comes to deep decontamination, we have run successful testing on how to decontaminate a bus or rail car or even aircraft.
Exactly.
And this is again one of the big benefits of using hydrogen peroxide vapor or gas, is that as it doesn't have any impact on electronics, for example, it can be safely used.
Yeah.
And for example, we just quite recently did a full decontamination of an operation room in the Helsinki University Hospital, and they had a very expensive equipment there. They had this operation robot and a lot of sensitive electrical devices, and they could all be left on location, and they got cleaned at the same time. So that's I guess it's enough proof that there is nothing so fancy in the bus that could be more vulnerable than a hospital operation room.
Yeah.
So as the air purification is an ongoing process, this deep decontamination is of course something that you do either on daily or weekly basis, depending on what is the threat level or if there is a known exposure. So for example, we did ambulances during the starting of the pandemics, when the staff wasn't sure that if the ambulance is safe to use or not. So we did a couple of those treatments and
with good results.
With very good results. It was about 1 hour from beginning to end of ventilation, and it was a 6-log result inside. Then hospitals. We already discussed this topic quite a bit. So I guess the same applies, but now you have large common areas there, like you have waiting rooms, you have corridors, cafeterias, public areas. So how would you use your devices in this kind of environment?
Well, I used to say even before the pandemic, I said that the most dangerous place is the waiting room of public healthcare, where you go and wait to get to the doctor or to the laboratory, and you're sitting among other people and you don't know what the neighbor next to you, what kind of disease he is carrying and what you self have, and we are all breathing out our viruses and bacteria in the air, and the neighbor is breathing it in as also. So these are the areas and spaces where continuous air decontamination is very good, and it's a very good application area for these kinds.
So even if the waiting room is way too big, it's still better to have some of the
it's
filtering
still better
technology.
to have. It's still better to have a few ones.
Yeah.
Even though you cannot filter as often as in normally in isolation ward, for example, in hospital, but all the filtering and all decontamination is good.
Yeah, and when it comes to deep decontamination of very large spaces, they can be segmented out with, for example, as simple as plastic, or take to attention the benefit that, for example, the coronavirus, as it's very vulnerable to hydrogen peroxide, this deep treatment doesn't have to go 6-log, because the coronaviruses get killed at about
Exactly.
I would say 1/6 or 1/5 of the exposure compared to bacterial spores.
That's true. Yeah.
Okay, so then shopping malls and very large spaces, I think everything as we have been talking about hygiene and fundamentals, they still apply. What makes me wonder personally is that shopping malls don't require people to use masks. In some countries they do.
In some countries, but not here in our country.
but I think they would have the right to do so. They can choose their customers. If they tell everybody that you have to wear a mask, then it's just about that everybody applies the same rule.
Yeah.
But now when we come to the air decontamination, shopping mall, that's a very challenging target.
Yes and no. Yes and no. Of course, there are people streams and a lot of people moving around in the shopping malls, and typically the air volumes are quite big. There are high ceilings and many floors and escalators and so on, and a lot of air volume in these shopping malls. And to clean all that air volume would be non-economical. It would not be economical to do it. In theory, it's possible, but it's better to apply the decontamination where the people move and where people stack up and where people meet and where they gather.
Elevators,
Escalators, service points, customer service points, cashiers, where people queue up and create small clouds of clean air and clouds of decontamination in these kind of places. So point of cleaning. And once again, all the cleaning affects the total
that's
cleaning
right.
air in the shopping mall.
Clean surfaces correlate to clean air. And when it comes to deep decontamination in a mall-like environment, the common areas, they are impractical in most cases, but lavatories, for example, changing rooms, individual shops, they can be periodically treated, so you can create sort of bubbles where you do the periodical
and
treatment.
then in the shopping malls, the individual shops, they are closed environments. They are pretty easy then to handle and decontaminate also with air decontaminating units on a continuous basis. But the public areas are difficult. But there you then have to apply points and create clouds of clean air.
On this slide, it will be available through our websites later on, but there is a link to a very interesting article authored by Dr. Ilpo Kulmala. It's about pandemic safety or generic microbial safety at airports, and it was written in 2017. But I read it through recently, and there was nothing, in my opinion, that was out of date.
Very much applies to today's situation.
It's I would say recommended reading after the seminar. Now we have also got questions from maritime industry, cruise ships and ferries, and now there is one good thing about ships. They have bulkheads. They have sections. So the same principles that make them more secure in times of, for example, shipwreck or sinking accidents, the same principles actually help in the decontamination processes, right?
Could help, yeah. But you could close down the ship in parts, but normally you don't do it when you are normally operating. And maritime industry is in very deep problems for the moment.
Actually, when I talk about the sectioning, it's more like a deep decontamination approach.
Yeah, that applies more for that one. But for continuous cleaning, we see the cruise industry, maritime industry is in very difficult situation for the moment, and it's much about how to creating trust among passengers and personnel, how to make it safe to travel on ships. Ships are more or less closed environments and with centralized ventilation system, and if something starts to spread from the central ventilation system, it spreads over the whole ship. Once again, applies the basic cleanliness, the basic cleaning and the basic procedures, and then in public spaces where the cruise liners want people to spend their time on board the ship, where you can then apply Genano method and clean those public areas.
Yeah, and the other side of the coin is that if there is a known exposure, the deep decontamination system, it can be applied cabin by cabin, or
Exactly.
section by section, or it can be a standard nighttime procedure in the kitchen areas or restaurants, and
That's also true. Yeah.
and if there is a larger outbreak, you can seal sections off for the treatment. That's one good thing about.
And then on the ships you can create so-called isolation cabins. If you have a case somebody is getting sick, then you can put those people or that person in an isolation cabin together with air decontamination unit and seal him and ensure that it's not spreading.
But I think we do agree that when it's a ship, which is a kind of closed society, the hygiene side and the preventive methods, it's more important than anything else.
That's also true.
Because once you have an outbreak, you are in a really difficult situation. So the procedures of keeping the weeds off is extremely important. We got some questions which I will refer at this point. So, for example, there was a question whether this material is available later on. Yes, a PDF.
Yes, will be.
And also the video recording will be available, and we will do our best to add as many subtitles as possible. And then there are questions also about how do we back up our claims of efficacy in various cases. So we just recently did a test with virus samples. I don't know if we got Dr. Kulmala back online, but anyway, he was conducting tests on various soft fabrics. Virus samples were put into the fabric and then treated with hydrogen peroxide, and then they were dissolved again to liquid and analyzed. And what the findings were, we ran multiple test series. This is actually one of them. And it turned out that under normal room conditions, 100 ppm applied to virus samples for 10 minutes only was sufficient to kill everything below detection limit. So we can call it full kill. And I was myself positively surprised about this, because as we always say, that when you have a decontamination procedure and if you have soft fabrics, you always have the risk that the microbes have been absorbed deep inside. But now we did a test where we had common fabrics used in transportation vehicles, and the virus samples were absorbed, but still they got killed beyond or below the detection limit. So nothing was found after this test was completed. So I guess this is very comprehensive proof for effectiveness of the gaseous deep decontamination. And also, when we get to the conclusions based on what we were discussing here, I would say that there is not one factor, there is not one single solution. It's a strategy which is combination of how people behave, how facilities are kept clean, and then the applicable methods of reducing risk further.
Yeah, that you can say in a simple way that there's not one method that fully applies. I think it's good what you said, it's a strategy. You need to have a strategy how to prevent from the viruses to spread.
Yeah, I mean, it's we have seen all sort of, how would we say, exploits on the pandemic situation, but I always use the term that you don't want to try to sell a sports car to somebody who needs a truck.
That's true also, yeah.
So certain things may be better for certain purposes, but I think with Genano and Cleamix, there is a very good combination of the available techniques of reducing the risk in workplace, public transport, and also in healthcare.
Yeah, and there's a lot of work and innovation and research going on now on how to apply these different technologies in different kind of applications. I'd also like to say for the end that, as I used to say, this is a matter also for everybody of us, because I tend to say that people can stay out of food and eating for 3 to 5 days, and most people in the world, they can choose also what food they eat. People can stay without drinking and water for 1 to 2 days, and the world is also becoming so good that most of the people in the world today can choose what they drink. But very few of us can stay without breathing longer than 1 minute, and nobody, or very, very few, can choose what air we breathe. So that makes it a matter of for all of us, and it's a global matter, and we need to apply it everywhere. Nobody can say that it doesn't concern me.
Exactly. There's one question from the audience. When considering usage of hydrogen peroxide gas to decontaminate, what is the cost-effective size in cubic meters? So that's a good question. It depends a lot on the size of the space and the materials. So an office environment like this, where we have some painted walls, we have some soft materials in furniture and so forth, for the 6 log result in a reasonable time, we're talking about treatment time maybe 1 hour, and the ventilation aeration time another hour or hour and a half. I would say that the good dimensioning is 1 unit per starting 100 cubic meters. I mean, one of these current units, they also expand by networking units together. So that's a kind of rough estimate. And if we talk about a laboratory where surfaces are inert, it's about 200 to 300 per unit. And that's for a short, reasonable treatment time. If we are given like 24 hours, then of course those figures can be much larger, much bigger. But those are the easy rules for defining what is the largest possible space. But there has been also this question I referred Satu earlier, is that how do we define clean air? And you said earlier in our discussion that clean air is something that you feel healthy and you feel secure and you don't get infected.
That's true. Yeah, there's a lot of definitions and standards around in the world, and almost every nation wants to give their own standard on what is good air and what is clean air. But common sense makes it that clean air is air that makes you feel good and well, and you don't get sick from it, and you don't get any viruses from it, or you don't get any diseases after a longer time. So that's the basic, I would say.
And of course, when hydrogen peroxide, for example, is used for decontamination, well, there are companies selling aerosol solutions which have been proven to be zero effect on any common bacterial samples or chemical indicators.
Let's say so that common sense once again, to add some compounds to the air and think that it makes it cleaner, that's against my common sense, that we should take away from the air and not add something to it.
Exactly. There's a question from the audience, is that are there scientific results or research papers on this non-thermal plasma method on effect on specifically on coronavirus?
Yeah, there are, and there's a number of scientific papers from around the world, and there's actually one paper under construction or under preparation for the moment by VTT, and people here in this webinar also are involved in this paper, and we are very much waiting for that paper to come out very, very soon, because it's hot stuff for the moment. But there are German research, there's French research, there's Chinese, there's a lot of stuff around, and they are all, or there's a compilation of these ones are also visible on the Genano website. So.
Okay.
But more is coming.
One other thing I guess we should say also is that where to get this technology. Both of us, Genano and Cleamix, we provide our technologies through our chain of global resellers and distributors.
That's true.
And they can be approached directly, and of course we are happy to take technical questions.
Yeah. Today Genano has resellers, active resellers in a little bit more than 30 countries where you can then get this technology and these devices. And once again on the website you can find the local reseller contact details. And
another question coming from the question stream. It's about, I think we covered this already, but is it possible to use Genano purifier in public transport like buses, trains, or even airplanes? I guess it's just the issue of having a power plug and space where to put it.
Yeah, having a place where to put it and how to fix it. Of course, you have a little bit to avoid vibrations. There are physical components that should not vibrate that much, but it's doable.
Yeah. So, concluding our presentation and discussion for today, as said, the safe, secure workplace and public transport during pandemic. It's not one thing; it's a triangle of things. One is how and what we do, the people and the cleaning methods and procedures. Then we have the continuous processes, which is air filtration, air purification, air decontamination, yes. And then we have the periodical part, which is the deep decontamination that leads scheduled cleaning and scheduled decontamination. And again, the more we follow this kind of procedure, the less risk we have, and we gradually decrease the risk. Now, of course, when you have a situation where you have a meeting room full of people, it means that there is increased exposure. So it makes sense, for example, that you have the continuous process to make sure that there is clean air. You have people wearing masks when applicable, and then if you have a next similar meeting coming up, it makes sense to give a little more deeper decontamination punch for the room. And this applies to transport vehicles as well. Okay, the question coming. What about the maintenance, regular cleaning of the filters? Do you want to answer first?
On the decontamination units. The Genano machines, the bigger ones, they have a built-in self-cleaning mechanism where it stops once a week for a few minutes and cleans itself with the washing liquid. And the only thing you need to do is to fill in washing liquid in the container twice a year around. That's enough to fill in the liquid, and cleans itself, and washing liquid vapors in the air then after the washing cycle. The active carbon filter unit needs to be changed around once a year, a little bit dependent on the amount of gaseous compounds it has been exposed to. This unit we have here in the studio for the moment, this is a simple, smaller mobile unit available on the European market for the moment. Will be coming also out on larger markets. This does not have automatic washing inside. It only has a active carbon filter here on top and the cartridge, and needs to be changed once a year.
Okay, then another question in the line for you as well. What about ambient conditions for your unit, humidity, temperature range?
Well, in our studies, temperature doesn't affect that much the cleaning efficiency. Humidity, well, you could say that higher humidity makes it even easier for us to catch the particles, and the cleaning function works better there. we have done environmental investigations in our laboratories and normal living conditions, yes.
Yeah.
It even works in the sauna.
Okay. And then there's a question for Cleamix. Availability of Cleamix devices. Yes, they are available through our partners globally. Well, actually, little correction. We don't yet sell in North America, but everywhere else. Then the same person is asking how many Cleamix devices you need to complete process for an office room, and what about personnel? So of course, when hydrogen peroxide decontamination is in work, the place must be vacant. You don't there no personnel should be in, no animals, nothing that you don't want to kill. So doors are closed. They can be also sealed a little bit. So sealed means that you tape the doors if they are not airtight. You shut down the ventilation system for the room, and then you do the treatment. And after the treatment is done, which is defined by either prior experience or indicators being used, then the room is ventilated that it can be used, and the total process time is typically 1 to 3 hours, including the aeration. And how many units you need, as said, without any other information about the location, we say that if you dimension it 1 production unit per starting 100 cubic meters, you are always on the safe side. But if it's an inert space like a lot of metal, glass, like a laboratory, then even up to 500. But in real life, we have been doing cases with 300 cubic meters per device, and it has still been reasonable short treatment time. Okay, so we don't seem to have any new questions if we don't have anything more coming from the audience. What about Satu? Do you have any thoughts on what we have concluded here? So are we on the right track in that sense?
Yeah, and I would like to once more remind that this the very first step that you mentioned in your triangle, the cleaning and general hygiene practices, they really are affecting to all these further steps. So if there is no organic soil that can protect the microbes, it's way easier to kill microbes with whatever technique, and so in that way it's good that you have that part mentioned here also.
Oh, there's other question just came in to Genano. How often should the air change in a safe environment? I guess that depends a little bit on how many people are there, but I think you said the 4 times per hour.
Yeah, that's the recommendation by the national health authorities here in Finland, that 15 minutes, and that means then 4 times. Certain hospital environments require up to 16 times.
But that's ventilation.
That's in isolation ward, for example. You need to go up to 16. Ventilation related recommendation are somewhere on 3 times an hour. I would say that when you go to 4 and 5 times an hour, you're on a very good level.
Okay, but that's about the changing the air. What if we have more like a static situation where the ventilation is not that good, but you said your device is running full filtering of the volume approximately 4 to 7 times per hour as well?
Yeah, so every time the air passes the device, it becomes cleaner and cleaner and cleaning. So it's a liquidation process.
But I guess it's a balance between the inbound air, number of people, and the size of the facility, right?
That's also, yeah.
All right. So if we don't have any further questions coming, I thank you very much, Nicholas, for coming. And
thank you.
Thanks for Satu. And unfortunately, we had some technical difficulties. Well, not technical difficulties really, but but our medical expert, Mr. Kuusela, he needed to go to attend an emergency.
Yeah, but that was more important.
That was definitely more important. So we couldn't discuss really about this airborne infection matters and things like that. But thanks for Satu, and thanks for the audience, and thanks for the studio crew. We say bye bye here, and we will have a next webinar on pandemic and decontamination related topics, most likely before end of the year. Thank you very much, everybody, and have an excellent day and be safe.
Thank you.
Thank you.